Here are some worked out more probability examples from chapter 5. Now, sometimes on the AP Stat exam, I'll see something given in just an abstract form, no context, no word problem. So this one says, suppose the probability of some event A is 0.35 and B is 0.6, and A and B, this symbol means and, whenever you see the upside down symbol there, is 0.27. Okay. Determine the probability of A with an exponent of C. Well, remember, that means complement or not A, if you ever see that. So then wouldn't that just be 1 minus 0.35 is 0.65? This is the probability of A or B, and that's equal to the probability of A plus the probability of B minus the probability of A and B. So then that literally is just the 0.35 given plus the 0.6 given minus the 0.27. So what is that? I believe that's 0.7 after you add and subtract. The probability of A given B is equal to the probability of A and B divided by the probability of B. So that would be 0.27 divided by 0.6. Grab a calculator and get your answer. Are A and B independent events? I did not review this in the previous review video, so here we go. Two events, A and B, are independent if the probability of A is equal to the probability of A given B. Well, you'll notice that the probability of A is given above to be 0.35, and then the probability of A given B, I guess I better grab my calculator and finish the answer to part C above. Waiting on my calculator. Okay, sorry, got to switch to another calculator. 0.27 divided by 0.6 is 0.45. Well, since those are not equal, then the answer is no. If they are equal, say yes. Suppose the probability that a construction company will be awarded a certain contract is 0.25. The probability of being awarded contract 1 is 0.25. And the probability that it will be awarded a second contract is 0.21. Probability of C2 equals 0.21. And the probability that it will get both is 0.13. Probability of winning both C1 and C2 is 0.13. What is the probability that it will win at least one of the contracts? Well, wouldn't that be equal to the probability of winning contract 1 only plus the probability of winning contract 2 only plus the probability of winning both? So in other words, it really just is equal to the sum of 0.25 plus 0.21 plus 0.13. And so then that equals 0.59, 59%. Now, remember that the probability of winning at least one is also always equal to 1 minus the probability of none. And so you could have come back up here and said the probability of winning none, and you could have figured that out to be 0.41. And so then you would have been down here 1 minus 0.41, and the answer is still 0.59. Sometimes you'll see in another example that plays to your advantage to use the complement rule. Okay, here's another two-way table similar to the review video. A researcher interested in eye color versus success in math collected the following data from a random sample of 2,000 high school students. What is the probability that a student from this group fails the math? 200 out of 2,000 is just the answer. But if we read this next problem, what is the probability that a student from this group fails given that he or she has blue eyes? So that's probability of fail given blue. Well, if you're given that their eyes are blue, it means it's one of these people. And of those people, 10 failed. So this answer would just be 10 out of 100. So hopefully you see the difference between those two. Are blue eyes and failing the math program independent or dependent? The probability of fail would have to be equal to the probability of fail given blue. Well, that's 200 out of 2,000 equal to 10 out of 100, question mark. Well, if I grab a calculator, 200 divided by 2,000 is 0.1, and 10 divided by 100 is 0.1, then we would say yes, they are independent. Example number 3. Of the 60 obese teenagers in a recent study, 15 had type 2 diabetes, 20 had high blood pressure, and 10 had both. Oh, sounds like a Venn diagram problem to me. So I'm going to come down here in this space that I have. Okay, and I'm going to draw a circle and label it type 2, and another circle and label it high blood pressure. Now, it says 10 had both. So I think I'll put a 10 here. 15 had type 2 diabetes, so I only need a 5 there to complete that. 20 had high blood pressure, so I need a 10 here to make high blood pressure a 20. Now it says 60 were involved in the study, but the sum of these numbers only adds up to 25. So 35 goes out here. 35 had neither type 2 diabetes or high blood pressure. Question A, given that the teenager has type 2 diabetes, what is the probability of having high blood pressure? So that's HBP given 2. So would that be the probability of high blood pressure and type 2 divided by type 2 using the conditional formula? So that would be 10 out of 15. These are the 10 that have both, and these are the people that have type 2, so it's 10 out of 15. If the obese teenager does not have high blood pressure, so that's given that they do not have high blood pressure, what is the probability that he or she also does not have type 2 diabetes? So it's the probability of not type 2 given not high blood pressure. Okay, well by the conditional formula, that's the probability of not type 2 and not high blood pressure divided by the probability of not high blood pressure. Okay, well, let's see how that's going to work out. Not type 2 and not high blood pressure. That's these people. Oh, so my numerator is 35. Not high blood pressure is these people do not have it, and these people do not have it. So that's a denominator of 40. So grab your calculator and get that answer. Example 4, the probability that Michael misses a free throw shot is 0.1 if he goes to the line to shoot 3 due to a foul shot on 3 points. So the probability of missing is 0.1, and just in case I need to know it, the probability of making is 0.9. What is the probability that he misses all three? So that would be miss times miss times miss. Well, that would be 0.1 cubed. Get your answer. What is the probability that he makes at least one? Makes at least one. Well, it would be far easier to say that that's equal to 1 minus the probability. Let's see, makes at least one. So that would be, the complement of that would be misses all. So if I take 1 minus the probability of misses all, well, that would be 1 minus the 0.1 cubed from the answer above. What is the probability that Michael makes the first, but not the second or third? So that would be a make, a miss, and a miss. That would be 0.9 times 0.1 times 0.1. Get your answer. Of the 10,000 freshmen at the University of Texas, 7,000 must take English, 6,000 must take history, and 5,000 must take both. Sounds like a Venn diagram to me. Okay, so let's see. We have English and history, and it says 5,000 must take both. So then 7,000 must take English, so put a 2,000 here. 6,000 must take history, so put a 1,000 here. Now, it's 10,000 freshmen. These three numbers only add up to 8,000, so there must be a 2,000 out here. What is the probability that the student must take English? Well, that would be 7,000 out of 10,000. Probably didn't even need the Venn diagram for that. What is the probability that the student must take both English and history? Well, that would be 5,000 out of 10,000. Suppose you learn that the selected student must take English. What is the probability that the student must take both English and history? So that's the probability that must take both, given that the student must take English. Well, that would be equal to, this is weird, both and English divided by English. Well, let's see, both and English. Well, that's these 5,000. And then must take English is 7,000. That one's kind of weird. Are the outcomes must take English and must take history independent? Well, let's see. In order for them to be independent, the probability of English would have to be equal to the probability of English given history. So that's a question mark. Well, let's see. The probability of English is 7,000 out of 10,000. Is that equal to English given history? Well, let's see. The probability of English and history over the probability of history is 5,000 over 6,000. So then, if I see that that's a 0.7 equals to a 0.8 something, then the answer is no, because they're not equal. Answer the question posed in part D if only 4,200 students must take both. So if this changes to a 4,200, then now the probability of taking English is 6,200 out of 10,000. And the other one would now be English and history would now be 4,200 out of history would now be 5,200. And so let's see, 6,200, that's 0.62. And then let's see, 4,200 divided by 5,200 is 0.80. The answer is still no. They're not the same. Example 6. 2 office assistants at this high school are responsible for getting the tardy list to the appropriate principals by 3 p.m. What good does that do, 3 p.m.? Rudy works on the list 30% of the time. So I wrote down P Rudy equals 0.3. Fawn works on the tardy list 70% of the day. So I'm going to put P Fawn equals 0.7. Okay, so they gave me that. Rudy fails to get the list to the correct principals on time, 10% of the time. So I'm going to put P Rudy late 0.1. And then let's see, Fawn, not much better, manages to get the tardy list to the correct principals 92% of the time. P Fawn on time 0.92. Now, I'm going to put in red some other things that I know that weren't given to me. The probability that Rudy is on time is 0.9, and the probability that Fawn is late is 0.08. So in red, it wasn't given to me, but it's intuitively understood. Let's say your principal sack and the tardy list is late. What is the probability that today Rudy was responsible for that list? Well, when I read these last 2 sentences, I have to understand that it's a conditional question. The tardy list is late. What is the probability of something given that the tardy list is late? What is the probability that it was Rudy given that the list was late? Well, that would be equal to the probability of Rudy and late divided by the probability of late. Well, let's see. Rudy late is 0.1. So it's just that Rudy late, given that was 10%. The probability of late is Rudy's late plus Fawn's late, 0.18. Now all you got to do is get a calculator out. Hopefully these extra worked out problems will be helpful to you.